Hey guys, welcome back everybody. Hope you all are doing great. Guys, topic for today is IP forwarding, which is very important topic for every network engineer. Because if you know how router is processing the traffic, then you can troubleshoot the issues on router very easily. And today in this video, we are going to understand step by step packet processing on router. So if you are a network engineer or if you are planning to become a network engineer, make sure you will watch this video till the end. Because at the last, I am going to show you practically also. Here in GNS3, you can see we have same lab. So I will show you the configuration also. Okay, and this is my scenario. As you can see in my topology, I have two PCs, PC1 and PC2. PC1 is using IP 10.1.1.1, PC2 is using IP 20.1.1.1. Actually, this side my subnet is 10.1.1.0/24, and this side my subnet is 20.1.1.0/24. And between PC1 and PC2, I have two routers, R1 and R2, and between routers, my subnet is 12.1.1.0/24. On router 1, IP address is 12.1. On router 2, IP address is 12.2. For an example, this is F0/0, fast Ethernet 0/0 interface of R1, and this is F0/1 interface of R1. Right? Guys, you know router maintain routing table to forward the traffic. So for now, just assume both routers have route in the routing table, like 10 subnet 10.1.1.0/24 and 20.1.1.0/24 subnets are available in the routing table of both routers, R1 also and R2 also. Correct? Now, when PC1 will send any traffic to PC2, how routers will process the packet? Let's understand. See, whenever PC1 will generate a traffic, right, any traffic, if I will talk about layer 3, like router forward traffic on the basis of layer 3 information, layer 3 means IP packet, right? Even before talking about packet processing, let me tell you what is IP forwarding. What is IP forwarding? Or what is IP routing? Routing or forwarding both are same. What is IP routing? So IP routing or IP forwarding is a process of receiving the traffic on one interface, receiving IP packet on one interface of router, then taking decision where to forward it, and then finally forwarding IP packet from another interface. That is called IP routing, right? So there are three steps. First step, receiving traffic, receiving IP packet, then making decision where to forward the traffic, and then finally forwarding the traffic from another interface. That particular thing is called IP routing. So there are three steps. Three steps involves under IP forwarding or under IP routing. So let's suppose the PC1 have generated one IP packet, any traffic, right? And I will talk about IP packet only. So here is the IP packet at layer 3. You know, under IP packet we'll have source IP, we'll have destination IP, we'll have protocol field, we'll have TTL value, right? And many more informations like sequence number, checksum fields. And after that, layer 3 will hand over it to layer 2, right? So layer 2 is going to actually add here Ethernet header. Now, if you don't know Ethernet header, then please let me know in the comment section. I will make one detailed video on Ethernet header. Like layer 2 here on the Ethernet link, how layer 2 protocol means ARPA protocol is going to encapsulate the frame, right? So actually at layer 2 here we will have Ethernet header plus Ethernet trailer. Ethernet header, then IP packet, payload, actual payload, and after that Ethernet trailer. If you don't know this, then please let me know in the comment section. I will make one detailed video on Ethernet header. Now this particular thing is called frame. Right? and PC will forward this frame to router frame, right? And above IP protocol, like IP packet, like layer 3, we can have many data like TCP or UDP based traffic. At application layer, it can be HTTP traffic, telnet traffic, doesn't matter, right? That not matter on the router, right? Under IP routing, we will not care about the actual payload. Router will only check layer 3 information to forward the traffic, right? It will compare destination IP address with routing table, and then it will take forwarding decision. So every router is going to remove layer 2 header. Okay, now, okay, wait, see, this is my frame. Now PC1 is going to forward this frame to router, correct? Router will receive this frame on which interface? Router will receive this frame on fast Ethernet 0/0 interface. What router will do? First of all, router receives the frame on F0/0, and then it will check the received frame check sequence, FCS, right? It will perform FCS checks. Let me write here, step 1. Router will perform FCS checks. FCS means frame check sequence, right? Now there is two chance. Maybe there is error in the Ethernet header, or there is no any error in the Ethernet header. If there is any error, right, router will perform FCS check to identify is there any error. If there is any error, then simply router is going to discard the frame. Router will discard the frame, and router will not check anything else. Simply it will discard it. But if there is no any error, then what router will do? If no error occurs, then router will check Ethernet header. And under Ethernet header, what router will check? First, router will check destination MAC address. If destination MAC address will match, then step 2. If destination will match, then step 2, router is going to check type field. Type field in the Ethernet header. First, router have checked Ethernet trailer, right? Under trailer carry what? FCS, right? So if there is no error, then router is going to check Ethernet header. If there is any error, then router will discard the frame, correct? If destination MAC address will match in the Ethernet header, in Ethernet header what information we have? Source MAC, destination MAC, and type field, which identify the upper layer protocol, right? IP protocol or ARPA protocol, right? The actual payload belongs to which protocol, right? How will identify the actual payload? With the help of type field in the Ethernet header, correct? So it will check type field. In type field, value will be type code of IPv4. So router is going to remove this header, trailer and header. Router step 3, type, after checking type field, it will extract layer 2 header, L2 header, and now the IP forwarding comes in picture. Router have removed layer 2 header. Now router have what? IP packet. Now router have actual IP packet, right? So now again there is two chance. It can be IPv4 packet or it can be IPv6 packet. Guys, in IPv4 header, right? If it is IPv4 packet, then in IPv4 header we have again checksum field, right? So first router will match the checksum. If checksum value will match, then router will accept, otherwise router will discard. Because again, if there is any error during the transmission, then checksum value will mismatch, then router will discard it, right? But if it is IPv6 packet, right? in case of IPv6 header, we don't have checksum field, so router will skip this step. Router will skip this state. Fine. So if it is IPv4 packet, then router will check checksum value. It will calculate their checksum and it will check checksum field. If both value will match, then fine, then it will accept, otherwise it will discard. Let's say checksum value is matched. Then what will happen? Then router is going to verify few things. Router is going to verify few things. Here we can say in step 4, verify what? Header checksum. Header checksum. Then step 5. Next step, what router will do? Step 5. Step 5. Now router is going to check is the router itself destination? Is the router itself the packet destination, like destination IP address is the IP address of router? Is the destination IP address of router itself? Now again there is two chance. Yes, destination IP address can be the IP address of R1, or destination IP address can not be the interface of R1, right? So if the IP address is the address of R1 interface, then router is going to check protocol field in IP header. In IP header we have protocol field, right? So router will check protocol field, and after checking protocol field, it will hand over the payload to actual protocol, right? Under protocol field is used to identify the upper layer protocol, right? Because see, the actual payload can be belongs to TCP, can be belongs to UDP, can be belongs to any layer 3 protocol like EIGRP, OSPF, or any other protocols, right? So if destination is router 1, then router 1 will check protocol value and it will hand over actual payload to protocol. But if destination IP address is not the IP address of router 1's interface, then what will happen? Then router will check next step. Step 6. Then router will check TTL value. Is the TTL greater than 1 or not? If TTL value is less than 1, then again router is going to discard the traffic. But if TTL is greater than 1, then router is going to compare destination IP address with their routing table. Then router is going to compare destination IP address with their routing table, and it will find exit interface, and then it will forward the traffic from that particular interface. This is the packet processing on router, right? But again, before forwarding the traffic from their exit interface, router will add layer 2 header. Layer 2 header. So how many things router will perform before forwarding the traffic from F0/1? Let's say inside this IP packet, source IP address is 10.1.1.1 and destination IP address is 20.1.1.1, right? So in the routing table of router 1, there will be one route 20.1.1.0/24, right? Reachable via 12.1.1.2, and exit interface is F0/1. This will be the route in the routing table of router 1. This will be the route in the routing table of router 1. So router will see, okay, destination IP address is 20.1. Let me compare this destination IP address with my routing table. In the routing table, route is available. Exit interface is F0/1 and next hop IP address is 12.2. Now router 1 will check their ARP table to find the MAC address of 12.2, right? And with IP packet, router is going to add again what? Here we have IP packet. IP packet. Router will add again Ethernet header before IP header. Ethernet header. It will calculate, and for the IP header also it will recalculate the checksum value. Router will recalculate the checksum value. It will add the new checksum value in the IP packet. It will decrement in TTL by 1, and then it will add Ethernet header plus Ethernet trailer, and after that it will forward the traffic from F0/1, right? So this is simple process when there is no ACL, no netting, right? Router is just forwarding traffic by checking their routing table. Router is processing their traffic by checking their routing table. Now I can show you this practically here. See, this is my topology. First of all, very quickly let me configure this topology. PC1, so IP interface brief. Okay, IP is not configured. Let me configure the IP interface F0/0, no cert, and IP address here I am going to say 10.1.1.1 255.255.255.0 exit. I am going to disable routing here because this is also router, but I am going to use this router as a PC, and then IP default gateway 10.1.1.10. Done. Then go to PC2, config T, interface F0/0, no set, and IP address 20.1.1.1 255.255.255.0 exit, no IP, routing, and IP default gateway 20.1.1.10. Right? Now R1, router 1, config T, interface F0/0, no set, and IP address 10.1.1.10 255.255.255.0 exit, interface F0/1 1/0, then no set, and IP address 12.1.1.1 255.255.255.0 exit. R2, config T, interface F0/0, no set, and IP address 12.1.1.2 255.255.255.0 exit, interface F1/0, no set, and IP address 20.1.1.1 255.255.255.0. Sorry, 20.10. Done. Now let me take you to R1. So IP interface brief 10.10 done. So IP route. So you can see we have directly connected network only, means PC1 cannot pin to PC2 now. Route is not available in the routing table of router 1 and router 2. Pin 20.1.1.1. Ping is not working. Ping is not working. But when I am pinging 20.1 from PC1, where traffic is getting dropped? On PC1? No. On router 1? Yes, on router 1. Even you can see, you can capture this link and then you can try to ping again. Here is the capturing. Again I can send ICMP traffic. You can see PC is forwarding traffic to router, but router 1 is sending error message, which is destination unreachable. Destination unreachable means route is not available to R1, right? And when PC1 is forwarding the traffic, you can see source MAC address is the MAC address of PC1, destination MAC address is MAC address of router gateway, and inside the Ethernet header we have type field. type code of IPv4 0x0800, right? Means actual upper layer protocol is IPv4 protocol. This is type code of IPv4 protocol, right? Even on PC you can check the ARP table. So IP ARP, right? Here is the MAC address of default gateway, you can see. So let me take you to R1 and config T IP route 20.1.1.0. Here I need to add 20 networks in the routing table of router 1, correct? Exit interface F1/0 and next hop IP address 12.1.1.2. Sorry, 255.255.255.0, exit interface F0/0 and 12.1.1.2, right? So here I have added the route. So IP route 20 subnet is there in the routing table of router 1 now. And on router number 2 I need to add 10 subnet. So say IP route 10.1.1.0 255.255.255.0 F0/0 and 12.1.1.1. Clear? Now PC1 can ping to PC2 20.1.1.1. You can see ping is working. So when I am pinging, what is happening? Source IP address 10.1.1.1, destination IP address 20.1.1.1. See IP packet, and after that we'll have Ethernet header. Here we have Ethernet header, and at the last we have Ethernet trailer. Right? PC will forward it to router 1. Router 1 is going to receive it on F0/0. Router 1 will first check FCS error. Right? If there is no any FCS error, then router is going to check Ethernet header. In Ethernet header, it will check what? This field, type field. Type value is type code of IPv4. So router 1 is going to remove this trailer and header, and it will hand over this actual IP packet to layer 3 IP protocol. Right? And now router is going to check destination 20.1.1.1. destination IP is 20.1.1.1. all right, is it the IP address of my interface, any interface of router 1? If yes, then router will check protocol field. In the IP header we have one more field called protocol field. Protocol field, even here you can see in capturing. Here you can see checksum, source IP, destination IP, and protocol. Protocol value is ICMP, right? So actual, or you can say upper layer protocol is ICMP, but will router 1 hand over it to ICMP protocol? No, because destination is not R1, right? So if destination is not R1, then R1 is going to check what? TTL value. If destination is not R1, then router will check destination, sorry, TTL value. What is the TTL value? TTL value inside the IP header is, here you can see, time to live somewhere. Time to live 255 greater than 1. So router will decrement in TTL by 1, and after that router is going to compare destination IP with routing table like this. So IP route 20.1.1.0 or IP address 20.1.1.1. Sorry, on router 1. So IP route 20.1.1.1, and then router will get to know, okay, for 20.1.1.1 we have this subnet here. In this subnet, destination IP address is matching, and my exit interface is F1/0. Next hop IP address is 12.2. Router will check their ARP table to find the MAC address of 12.2. So IP ARP MAC address is available. So router is going to add again what? Ethernet header. Again it will recalculate. See, in the IP header, what will be changes? In the IP header, router is going to recalculate the checksum value and it will decrement in TTL by 1. And after that, it will add Ethernet header. Ethernet header and then Ethernet trailer. Ethernet trailer, and then it will forward from F1/0. In the same way, router 2 is also going to process the traffic, right? So this is how router is processing the traffic, right? IP forwarding. Hope it is clear now. If you have any question, guys, if anything is not clear to you, please let me know in the comment section so that I can make another video on it. If you have learned something from this video, if this video is helpful for you, then please hit on like button, right? And if you want a video on any other topic, then also you can let me know in the comment section. That's all for today. We'll meet soon in the next video. Till then, stay safe. Bye bye. That's all for today. Thanks for watching.